Let us take the Laplace transform now. Let us determine the Laplace transform using the first principle. Just write down the question here. Determine the Laplace transforms using first principles. Now let's determine using first principles. If the first one, f of t is equals to 3t squared, how would you find the Laplace transform from first principle using this? So an integral from 0 to infinite of 3t squared e to the power negative st dt. So to take the Laplace transform of this, we need to place it to this formula, and we need to know, okay, this thing here is integration by parts, so it's s di, so it's plus, this is going to be 3t squared e to the power negative st minus 6t minus 1 over s e to the power negative st plus 6 1 over s squared e to the power negative st minus 0 negative 1 over s cubed e to the power negative st. And then that will multiply that, will multiply that, will multiply that. So it's going to be negative 3t over s e to the power negative st minus 6t over s squared e to the power negative st minus 6 over s cubed e to the power negative st between 0 and infinite. So we need to substitute infinite. When you do the k thing, this thing is 0 here, this thing is 0 here, this thing is 0 there, right? So everywhere here, this thing is going to be 0, so it's going to be 0 minus. If you substitute a 0 here, this thing is 0. If you substitute a 0 here, this thing is 0. But when you substitute 0 here, this thing would be negative 6 over s cubed. Like that. Which is 6 over s cubed. Now it does make sense because the Laplace transform of t squared, it is 2 over s cubed. By multiplying this by 3, I'm also multiplying this by 3 to result onto that. So this is how you do the Laplace transform from first principle. Right. Number 2, your f of t now, it is e to the power negative 2t. So integral from 0 to infinite. I'm no longer going to do this thing for k. You know you need to do it. So it's e to the power negative 2t times e to the power negative st dt. The bases are multiplying each other. Simplify. E to the power negative in bracket s minus 2, s plus 2 t dt. Right, so by integrating this, you'll see that you have an integral of negative 1 over s plus 2 e to the power negative s plus 2 t between 0 and infinite. And then substituting infinite to this thing is going to be 0 minus substituting 0 here, it's going to be 1, negative 1 over s plus 2. So your final answer should be 1 over s plus 2. It does make sense again because the Laplace transform of e to the power negative at, it is going to be 1 over s plus a. It does make sense, right? So the third one, by using the first principle, is that number 3, if your f of t, it's going to be t squared for, it's going to be 4t, t squared e to the power 4t. How can you do this? You're going to say an integral from 0 to infinity of t squared e to the power 4t times e to the power negative st dt. But these two will combine. In that case, I have an integral from 0 to infinity of t squared e to the power minus in bracket s minus 4 t dt. Right? And then to integrate this thing here, we need to use LIATE, or the tabular method, which is integration by parts. SDI. So this is plus, this is t squared, this is e to the power negative s minus 4 minus, this is 2t, it is negative 1 over s minus 4 e to the power, it's shifting, e to the power negative s minus 4t plus derivative 2 to 1 over s minus 4 all squared e to the power minus s minus 4t minus 0 integral negative 1 over s minus 4 all cubed e to the power negative s minus 4t. And then the procedure, you know the procedure of doing this table, right? So now you need to have t squared e to the power negative s minus 4 t divided by s minus 4, this thing is negative, minus 2t e to the power negative s minus 4 t divided by s minus 4 t squared, and then minus 2 e to the power negative s minus 4 t divided by s minus 4 cubed, like that, s minus 4 cubed, like that, between what, 0 and infinite. You know exactly whenever you substitute infinite to one of these things, I'm going to get what? I'm going to get 0. Now if you want to substitute this 0 here, you need to subtract, and you know when you substitute 0 here, this thing is going to be 0. When you substitute 0 here, this thing is going to be 0. But when you substitute 0 here, this thing is going to be negative 2 over s minus 4 all cubed, which is the same thing as 2 over s minus 4 all cubed. Now, what you see here, you are witnessing something called the first shift theorem. This is the proof of the first shift theorem that states that when you take the Laplace transform of e to the power at times f of t, the answer to this is going to be f of s minus a. So this is your first shift theorem. By the way, do not stress too much. Do not stress too much on these problems. And then I'm just going to do the last one. I'm not going to do the last one using this procedure that you see here, but I'm going to use another method. So this is number 4, this is number 4. So now your f of t, it is cos 5t. From first principle, how would you do this? So it's an integral from 0 to infinity of 5 of cos 5t e to the power negative st dt. Again, to do this, you need LIATE. To do this, you need the table again. So let us just do it. SDI plus, what is the derivative here? Cos 5t, your integral e minus st minus, what's the derivative of cos 5t? It is minus 5 sine 5t, integral is negative 1 over s e to the power negative st, plus the derivative of negative 5t, it's negative 25 cos 5t, and then your integral, it is 1 over s squared e to the power negative st. Now we have a problem here, is that when we integrate this thing here, the function that we have, the first function that you have here, it's repeating here. So what would you do? To do the calculations in this case, take that, multiply that, take that, multiply by that. So I'm going to say it is negative 1 over s cos 5t e to the power negative 5 negative st, and then it's going to be positive 5 sine 5t divided by s squared e to the power negative st. When you are there, you're going to integrate this product. And equate it to the original equation. So it's going to be minus an integral of 25 cos 5t over s squared e to the power negative st dt. This thing will equals to the original integral from 0 to infinity. Put the dash line from 0 to infinity also there. So it's from 0 to infinity cos 5t e to the power negative st dt. These two integrals are identical. 25 and s squared are just constants. You can just calculate it on both sides. So if you do that, I'm going to have an integral from 0 to infinity of cos 5t e to the power negative st dt in bracket 1 plus 25 over s squared is equals to, when you substitute infinity to one of, even you substitute infinity here, this thing is 0, but when you substitute 0 in here, the only thing that is going to be left is just 1 over s. it is just that 1 over s. If you simplify it, can you please simplify this part for me? You'll see that it's going to be 1 over s, because infinity here it's 0, infinity here it's 0, right? But when you substitute this 0 here, this is 1, that is 1, this is 0, that is 1. So that's why I'm left with that positive 1 over s, because you need to subtract also. So simplify. So 1 plus 25 over s squared is the same thing as s squared plus 25 over s squared. By multiplying it on both sides, multiply everything here by s squared over s squared plus 25. I'm going to get an integral from 0 to infinity of cos 5 t e to the power negative st dt is equals to s squared divided by s in bracket s squared plus 25. So therefore, an integral from 0 to infinity of cos 5t e to the power negative st dt is just s over s squared plus 25. So you can use this way to prove this theorem here, to prove this theorem there. We can use that way to prove this theorem. Right, so this is the first principle. So this is question 1, giving you the answers now. This is question 1. So whatever we did in this video, it may be question 1 of your exam this year. So thank you so much. Bye.